Hi, everyone. Thank you for joining Reline Live. I am joined today with Cullm Walker of Infrasteel. He is going to give us a product overview. He's also going to give us a few case studies of examples of where this product has been used. And then at the end, we are going to be showing you a super cool new tool that his company's been working on to evaluate Reline options. I have a feeling we're going to get a lot of questions on this, but we'll kind of wait and see until he kind of gives us a sneak peek of it. Hi, Cullen. Welcome. Thank you for joining us.
Hey, Cassie. Thanks for inviting me.
Yep. I am on your newly launched website, which looks fantastic. I'm going to share my screen so everyone can see. Here we go. I am the presenter. Let's see here. Show my screen. Okay, you should be able to see my screen. You see it, Cullm?
Yep, I got it.
All right. So give us a little intro on this product, and then we'll dive into some of the use cases.
Well, our background as a company, Precision Pipe, we sell round structural steel pipe to the primarily for road boring. So a lot of what we sell and have sold for 30 plus years is round pipe for jacking and boring under roads. We were selling a lot of material to a contractor in Virginia, and we thought he was jacking and boring it all, but the Virginia DOT has offered methods A, B, C, D, and E as their pipeline, their culvert rehabilitation methods. And at the time, we were method E. Method A was replace, cut the road in two and replace it. And at one point, the contractor came to us and said, you know, can you match the shape of the existing arched culvert? And we figured out how to do that to get measurements out of the existing structure and match the radii of the liner to the radii of the hose pipe. And once we did a few hundred of those, we were like, this is going pretty well, but we were able to not make just one piece that matched that shape. You know, oftentimes it's 10 or 20 pieces, and because they have to be welded up to each other, so they have to match up because we have welded joints. And we said this is going pretty well, so we decided to market it nationally, and we trademarked the name Infrasteel, and went around the country to different DOTs getting approved.
Awesome. So should I maybe show that cool video that you have that shows a kind of an overview? Do you think that would be worth showing? It's about a minute long, right?
Long, yep.
Okay, I think this is, let's click on this.
Has it started yet? Yeah, so this was done by Parker Ruiz and at signaturemedia.com, who also helped us with this new website. But it shows the the liner being welded up and slip lining it into the existing structure. The grouts being, because it's steel, we can put grout ports where it needs to be. And so these grout ports, pardon?
Don't you get asked a lot about grout ports?
I do, yeah. And we can either weld in 2-inch grout ports at the plant, or they can be welded where they're needed in the field. And the grout, having to use grout tubes, they can do just like in the video and hook the hose up to the grout port from the ID and pump from the ID into the annular space.
Okay. While I'm thinking of it, and I didn't say this in the beginning, a lot of people who are on though have joined Reline Live before. We want questions. That's why Cullm and I are here. So use that question box. Ask anything that you want answered today. If we can't get to it, we will follow up with you separately. But this is supposed to be an open Q&A, so please let us know what questions you guys have. So one thing I thought was really cool on the new website was your case study section. and you guys have done some really cool DOT projects. Should we show the group some of those?
Yes, let's look at some. We've got 3 on the website that come in handy. There was a big project that bid last week, and one of these case studies was helpful to the bidders because it was a similar project.
Which one would you like me to go to first?
Well, we can start right here where you are. So this was well, that's a good one too. But
Skipped ahead on you. Okay.
So this was in Miami County, Ohio, and it was a 245 foot long, 135 inch ID liner that was 3/4 of an inch thick that went inside of a 144 inch failing CMP. And you can see the contractor has welded those joints up in that picture and is getting ready to push those into the existing structure.
Mm-hmm.
So most often the joints are welded and pushed into place. However, they can be put into place, positioned into place, and all welded from the ID. We would typically set up a bevel configuration with an inverted bevel on the bottom so that the welder does not have to get up underneath the material, and then the sides and top are welded from the outside.
Okay.
Yeah.
So here's a little bit. One thing I've never thought to ask you is, do you get requests for fish passages very often?
We do, and so because it's a steel product, after installation, it's easy to weld in fish baffles
Okay.
into the invert. And you can see in that picture, that's so the liner shipped with cross bracing in it that's taken out after it's grouted, and in most cases the contractor will choose, and we suggest that they put in a light rail system in the bottom of the existing structure, and you can see that in that picture. And it might be out of some bar stock or small channel or angle iron or even square tubing. But,
Yeah, just slide it in.
And it slides into place well. It always slides in easier than the contractors think that it is. This installer is a big boring and jacking, and so they, if they're used to jacking and boring, they come to something like this, and you can see the other end. I mean, it's gravy for them. So they just use their jacking machine to push it into place.
And here's some pictures from the project, right?
Mm-hmm. Yep. And yeah, they're just they're pushing, and you can see in those bottom 2 pictures as the liners coming in closer.
So we have a question that came in, Cullm. How much room should be allowed to slip line? We want a pipe as large as we can realistically slip in, so it's not loose.
So we started with what Virginia was specifying at the time, and that was allowing for 3 inches of annular space. So as a starting point, we'll downsize 6 inches smaller than the existing structure to allow for 3 inches all the way around. But oftentimes it might be tighter than that in a certain spot, or there might be more annulus. But downsizing, if somebody was calling me today and said, I've got a 145 inch by 110 inch arched failing structure, can you give me an estimate? I would start by downsizing those measurements 6 inches.
Okay. And that also depends, to kind of expand on that, and I know you can add to this. In my experience, it really depends too on any deflections you have in the pipe. How do you guys handle that, Cullm? Like if there is any sort of collapse, do you guys downsize to make up for that collapse, or do you suggest that they go, I'm using my hands on my screen.
Yeah.
You suggest that they go push it back out as much as possible so that they don't lose capacity? So
it depends on how far gone the existing structure is. So if you have that spot that's 4 feet 4
Yeah,
feet in the top coming down. You know,
Yeah.
you can oftentimes we can either build a conical lead piece, or the contractor might pull in with chains and come-alongs, pull the top down a little bit and get past it, and it pushes it back up into place. If it's too far gone, if it's like that all the way through the structure, then we can size the liner, you know, to take that into account. And then I've also seen contractors cut out a foot at a time and push forward, and cut out a foot and push forward.
So it sounds like it's used like, I mean, slip lining is all about the condition of the current pipe and any deflections or any sort of, same thing with your product. You grout the annular space after it's in there, and that, especially if you're using a low density cellular grout, right? It's going to fill all the voids, even if there's some areas infiltration for water, right?
Right. And when one of ours jobs is finished, you know, there's one solid steel sleeve, and there's no joints for that'll fail, like you know, most of the existing structures, when you see them failing, I mean, there's something going on at the joints. And there's voids behind those in a lot of cases. But once we're inserted, it's a solid steel sleeve, you know, with the annulus filled with grout, and we can take, you know, then after it's grouted is when we take out the cross bracing.
Right. So what is the purpose for those cross bracings?
Well, we started off doing it to help the liners maintain their shapes as they were transported, and then we realized that they needed to stay in place until after the annular space was grouted. So each segment has a set of bracing at each end.
So at each joint, essentially, let's call it a joint, right? At each end, before where you would join the two together, that's where you have the bracings?
Yes, okay. And as you join one together, you can take out one set and leave a set. So the welders, you know, it's easier for them if they take out, as you put the two joints together and you have two sets that are a foot apart, then you can, you know, take out one set and leave that set there. The cross bracing also helps them align the joints, and which is important to them. They can kind of match up one set of cross bracing to the next, and know that the radii are matched up.
Okay. I'm going to click on this one. I think this is the Chapel Hill, right, in North Carolina. You and I kind of talked about this one a little bit.
So these were 3 barrels under Elliott Road. The North Carolina Department of Transportation was doing some inspection on some big box culverts that were about a couple hundred yards from this site. And then they, you know, they took notice of what was going on with these structures, and they went ahead and inspected it and sent it to the town of Chapel Hill. The town, there was already flooding in this creek that had been occurring upstream, and the town had already hired hydrostructures to help them with their you know, hydraulic requirements, and you know, improve the flow of the creek. And it was hydrostructures that approached us. They did they actually used the matrix that you mentioned earlier that we're going to go to help them evaluate all the different products that were available to them to fix these liners. And Cassie, you and I have talked about it. I mean, that your view and our view is the same, that, you know, the same product's not the best choice for every failing culvert. And we know the ones that we're good at, and but offering this tool that we're going to get to later is a way for people to do their own analysis of the other products available to them for that particular site. So in this site, obviously we were chosen, and there was the existing structures were 190 by 102, these 3 barrels, and we ended up getting putting in a 180 by 105 liner, a 1/2 inch thick.
Do you mind me asking what other options they did consider or were even in the running before your product was chosen?
They looked at and we used their analysis as sort of the benchmark on the worksheets, because it was it gives you an idea of how they looked at it. But they were looking at they looked at several spray-on liners. They looked at polyethylenes. They looked at round pipe options. They even looked at a round steel liner option. And flow capacity was their most important criteria that they were trying to meet for this site. And we'll look at that in a little bit. But yeah, they looked at 9 or 10 different products. 8, 9, or 10.
Okay.
So here's one of those places you were talking about a minute ago. This is the idea of the failing liner. You know, it's kicked in significantly.
Mm-hmm.
And the contractor did bring in that end of the liner and pushed it past that spot. So that's the inlet. He didn't have very far to go, but he got the front end of the liner. He brought it down in that place and then released it once he got past it, and the liner sprung that back into place.
I'll scroll down to some of the other pictures too. Oh yeah, really cool pictures on this project.
Yeah, the top left one there is the completed project. And let's see, so one of the big hurricanes hit the area. It's in that case study just above that. It was a major hurricane. Go back up, scroll back up to the case study just a little bit. I can't remember, stop right there. See at the bottom. It's the last paragraph I mentioned which hurricane it was, I believe. But the it came in right after the
was it her? Oh, not Sandy. That hit New Jersey.
it was right before Sandy. Maybe it's down below that. Anyway, one of the big devastating hurricanes hit South Carolina and North Carolina, and of course they're not on the coast there, so they didn't experience the coastal damage, but they did get the flooding.
Right.
And the engineers and the town of Chapel Hills engineers went out to the site, and they were very happy with the Hurricane Matthew.
Yeah, I saw it.
Yeah, but it performed well right after the hurricane, during the hurricane.
Great.
Yeah. As a matter of fact, I talked to a contractor yesterday. That was something else that was important to them, is extending. They're going to widen Elliott Road, which this was under, and so each barrel is going to have a 25-foot extended piece welded to them to allow the road to be widened, and that should be under construction sometime this summer.
Okay. So that's another, I guess that's another interesting part of your product, is that when they want to expand the road, they can come in and do things like that versus having to put in something new because you're already a steel plate under the road like you would be a CMP or something else, correct?
Right.
Cool. Right. I think we have one more really neat case study to go through, and then we will show people the worksheet.
Okay.
The pipe rehab worksheet, which I think is going to stir a lot of questions.
So this case study is pretty typical of the type of thing we go through. We were first, asked to come out and look at it. This was the under Op 465 in Indianapolis, and the DOT was looking at all their different options, and so we provided them an estimate. We had load calcs run on it to meet their load bearing requirements, and we built in a design life to the steel. We've got an extra copper component in our steel liners for corrosion resistance. And then, so once the load calcs are done to determine the thickness that will handle the load, we add back steel for each year of design life that the owner needs. And, that's just how we do all our stuff. So Um, you can scroll on down. So I-465 in that area had a lot of traffic. Cutting the road in two just wasn't really an option. This was 215 feet. The existing structure was a 199-inch by 121-inch arch. And we put a 184 by 111 by 111 liner in it that was 7/8 of an inch thick. What happened, look, this picture is kind of interesting because, you know, a couple of years went by before it was coming out to bid and we were chosen. And right before the bid, the letting, the road caved in. So what you're looking at there, you can see the back end of a truck at the top of the picture, and you can see the sign. So the edge of the road, the edge of I-465 collapsed. And then you see, as you know, as you move toward the front of the picture, it allowed the contractor a staging area to lay the liner sections into. It's almost like a bore pit. And so this is where they're making the new head wall. Those are the forms for the head wall at the inlet. And then the picture was taken from the top of a different culvert that feeds into that culvert that's not attached to it.
Oh, okay. I'm gonna go down to some of the pictures down here. So one question that came in was, do you need to be a certified installer for Infrasteel, or what does that look like if it's a product that someone wants to try?
No, you don't have to be a certified installer. As a matter of fact, there's different types of contractors that put in our material all the time, and a lot of them are local contractors that work in a given area, and you know, they do a lot of DOT work for a particular DOT.
Okay.
And you know, it's really not very complicated. It's as most slip lining products aren't complicated. The welding time is sort of the downtime in the project. Sometimes, you know, certain contractors might not have many welders on their crew and need to bring in a third-party welder. But and that's what happened in this case. In this case, it was 215 feet long. The contractor chose to line the barrel with the liner, and then all the welding was done from the inside. And it took they had a pretty hot shot welding crew, and it took them 21 days to do the welding. And the whole job, it came in under just under $1 million to do the whole thing.
How small of a size can you go down to, since you put the bracing inside and those have to be taken out after?
So the small stuff that's sort of our limitation. It takes big rolls at the plant to roll this steel. And so when we get down to sizes sort of in that 42 to 36 range, it's sort of how tight are the radiuses or the radii on the outside.
Okay.
So, you know, a span of, it's the rise measurement that usually, that's kind of where that's if it's a short rise and a short span being in that 42, say it's a 42 span by 30-inch rise, it's going to be, that would be, you know, depending on the wall thickness too, that factors in. So if it was a 1/2-inch wall liner, that's easier to get those radii to match as it would be turning a 1-inch piece of plate. So it's a little bit subjective. So it's not like but that's in the range. So it sort of depends on the shape and radii. But and then on the large end of the spectrum, we're good. We know that we're up to 20 feet. We can meet the load bearing requirements in the span. Usually, if it's over 20 feet, we start to sort of get the load calcs don't usually work.
Okay. I don't know a product that goes over 20 feet for slip lining. I can't even think of one in my head.
Yeah, I mean, most culverts aren't that. Yeah, so we haven't had to turn something like that.
Yeah, so we're getting close on time. I want to give everyone a sneak peek of this worksheet. We're going to just put it out there already. Cullm and I know we're going to get so many questions that we're going to do another Reline Live just dedicated to this worksheet and going through step by step what everything means and how they came up with the calculations and the numbers. And all this kind of stuff. But I do want to show it. I think it's important. I think you guys will be interested in it. So let's start maybe on, what do you think, Cullm? Just start by maybe telling them why this was created, and then we'll talk about how you rank things and kind of give a quick, like, I mean, this is very much an engineering tool. You and I talked about that, but
Yeah.
it's still really cool. I think we just, the step by step is going to take us probably 30 minutes to go through.
And it can be downloaded for free from our website. You just got to, well, if you put in your email address, it'll send you a copy of this Excel spreadsheet. But
Right.
so this is what hydrostructures used, this method to evaluate their different products for that Chapel Hill job. And so here, the set criteria on the left, they're set. So we decided to just use 10 criteria. Then that middle column, the user puts in ranks what's important to them from 1 to 10. So in this case, flow capacity was 10. The user, if he wanted to put flow capacity at 8, would just change that number to 8 and go right on down the list, plug in what's most important to them from 1 to 10, 10 being the highest.
Okay.
Here, contractor availability was the lowest. And so in step 2, you put in the product that you're evaluating. And here the Infrasteel is carbon, it's a smooth wall carbon steel liner. They looked at a smooth wall round pipe. These different, you can just go right on down the list.
Yeah.
And then you can
just what you would consider most common, right? I mean, we run into spray liners, we run into slip lining with our, I mean, but these are really, like, if there's more to add to this list, if people think that it's relevant, they can add to this list, right?
They can add or delete. There's a place to add additional ones at the bottom, and you can delete the ones at the top that you don't want to use.
Okay.
And it just all moves, it all works going forward.
Okay.
From one page to the next.
Yep. So then we go to evaluating your options. And
So
this is where we'll dive in next week or whenever we get you scheduled, because this is where the engineer does have to put in some work.
He's got to put in some values here in each of these cells.
Okay.
Then on the last page, it calculates out the score.
Okay. I know this is gonna, like I said, I know we're gonna get a lot of questions on how we're already getting some, so we're gonna address these. If Cullom can get on next week or the week after, we'll do a whole 30 minutes on this tool, you guys. But like he said, if you want to put in your information on the website, you can get this automatically emailed to you, and you can start playing around with it. Cullom sent it to me a couple of days ago, and I've been messing around, and I know I already have lots of questions. So I think it'll be really neat for us to go through this in detail and maybe take some example projects. What do you think? Like, maybe get an engineer to give us real example numbers.
Yeah.
We could put, yeah, I think that's what we'll do. I think that'd be a great Reline Live. So I do have a question for the group. I see we still have almost everyone on, even though we're hitting our time. There is a raise your hand button. Can anyone raise their hand if they have heard of Infrasteel? I am curious, before this Reline Live, if they knew of it. Okay, so we have about almost no one. Okay, a few people. I know a couple of the names, some I don't know. Okay, so it looks like a lot of the DOTs on here, Cullom, have never heard of Infrasteel. So I'm glad we did this.
Yeah, me too.
I think that this was a good one.
We had done so many of those in Virginia. When we went out, the first place we went to was Caltrans, because we knew Caltrans was tough, and they spec'd us in 3 months. And engineers out there laugh at me when I tell them that, but Caltrans had studied every product in their system, and carbon steel plated inverts held up better than anything else to abrasion. So it was already approved before we ever went, basically.
And I think for some of the manufacturers that are on the call, I know we have a couple of other manufacturers on the call, as well as a lot of DOTs. This is approved already with Caltrans, with New York DOT. Some of the toughest DOTs in the country already accept this product. Indiana, not an easy state to get products approved. So congratulations. Texas. I mean, I know when I was running a manufacturing plant, we were, never got Indiana approved.
Well, they like us.
Okay,
And I
good.
appreciate the
That's a tough one.
opportunity. Thanks for inviting me.
Yeah, thank you so much, Cullom. Okay, you guys, so tvpipesolutions.com, go to Reline Live. I'm going to get with Cullom right after this, figure out his schedule, and then I will be sending an email out to all of you guys with the follow-up on just this worksheet. We'll get him on and we'll have a deep dive for 30 minutes in just this. So
Sounds good.
you guys. Yeah, thanks for joining, Cullom. I really appreciate it. And I'm going to see you again soon, obviously.
Okay. Thank you, Cassie.
Thank you. Bye, everyone.
Bye-bye, everyone.